Hello, this is going to be lesson 3.1. We're going to be talking about rational numbers today, and there's a lot to cover today, so let's get started. I'm going to put myself smaller here as we go into the lesson. So 3.1, we're going to be classifying rational numbers. We have several standards that we're working on today, or several objectives. I can write mixed numbers as a fraction. I can write decimals as fractions, I can write whole numbers as fractions, and I can classify rational numbers. That's a lot in one lesson, so if halfway through the lesson you want to take a break and then come back, feel free to do so. This is stuff you would have learned last year in 5th grade. However, it's been a while, so I want to review some of this information. The standard is going to be 6, NS 6. Understand a rational number as a point on the number line. Extend number line diagrams and coordinate axes from previous grades to represent points on the line and in the plane with negative number coordinates. So we're mainly going to be working with the first part of this. Understand a rational number as a point on a number line. We will get through the whole standard throughout the year. So now I'm going to minimize myself so you can see the whole screen, and let's get started. So first of all, it would be good for us to remember what a fraction is. This is probably a review for you, but it's good to go back and think about what is a fraction. So we have this box cut into 10 pieces and 3 of them are colored in. How would we write the colored in portion as a fraction? Well, we would write 3/10. Why would that be? The 3 stands for the number of green squares, and the 10 stands for the number of total squares. So we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And notice also that the pieces are cut in equal sizes as well. We can also call the top number, the 3, a numerator, and we can call the bottom number, the 10, a denominator. Let's try another one. Here we have a certain portion of our box colored in. What fractional part of this object is colored in? Well, it would be 7/12. Where do I get that? The 7 comes from the green squares that are colored in. 1, 2, 3, 4, 5, 6, 7. And the bottom number, the 12, comes from the total number of squares. We have 12 pieces there. The 7 is called the, I hope you're saying numerator, and the 12 is called the, I hope you're saying denominator. Okay, great. Let's move on. Okay, here's my little baby that says the division symbol in math is a fraction bar without numbers. Okay, that will make sense to you now when I show you this. So fraction is really a division problem. What do I mean by that? Well, here's 3/10, and that is really 3 divided by 10. You're saying 3 divided by 10, yeah, it's going to be a number less than 1 because a fraction is a number less than 1. Another way of writing 3 divided by 10 is to show our, I call this our house. It's just the name I've given it. And I can divide 3 by 10. So where does the 3 go in the house? Let's take a look and see if you can figure it out. Where am I going to put the 3? The top number of my fraction is always, always, always going to go, where do you think? Inside the house. I call this inside the house right here. Okay. What about the 10? Where does that go? See if you're right. Where is it going to end up? Almost there. Where's it going to be? And it stops there on the outside of the house. And the answer, called the quotient, is always going to go on top of the house. So always remember where to put your numbers in a fraction when you're dividing. The 3 goes on the inside of the house. So here's a little, what is that, an eel? Only a fraction of you will understand the fine line between a numerator and a denominator. The fine line is here, right? The numerator would be like a 3 and the denominator could be our 10. So now do you get that? The fine line between, yeah. Anyways, let's move on. Okay, so fractions represent division. Let's try another one. We have 7/12. That means 7 divided by 12. Or you make our house. Where does the 7 go? Let's follow its path and see where it lands. Hopefully you've already figured it out that the 7 goes under or inside of the house. Inside the house. Where does the 12 go? You've only got 2 other choices, right? You can say on top of the house or outside of the house. And I hope you said outside of the house. That's where the 12 goes. Okay, it's your turn to give a few problems a try, and I will see you back shortly. Okay, welcome back. Hopefully you did well on those questions. Let's move on. Let's do a definition. A rational number. What is a rational number? It's any number that can be written as A over B, where A and B are integers and B is not equal to 0. That's a long way of saying that basically a rational number can always be written as a fraction. Don't let the A and the B fool you or get you confused. This A or B just means a fraction. And B can never, never, never be equal to 0. 0 is a no-no for a number on the bottom of a fraction. It's called undefined, cannot be determined. Okay, so a rational number is basically a number that can be written as a fraction. Let's take a look a little bit more here. So now we're going to be writing mixed numbers as fractions. Why? Because mixed numbers that can be written as fractions then would be called rational numbers. So we have 3 2/5. Why is it a mixed number? Because we have a whole number 3 and we have a fraction 2/5. It is a mixed number, mixed with a whole number and mixed with a fraction. We can write it completely as a fraction. How do we do that? Well, this mixed number can be rewritten as a fraction. Therefore, it is a rational number. So here we have, I'm drawing a box. So I want to get 3 holes, right? So I have to color in 3 whole boxes. So let's color in. I'm cutting them into 5 pieces because my denominator is 5 pieces. My boxes have to be cut into 5 pieces. So I need 3 whole boxes. So far I've got 1 whole box. I colored in all the pieces. All the pieces colored in makes 1 whole. If this was a rectangular pizza, I would have 5 pieces there. And if I ate all 5 pieces, I would have eaten the whole pizza. I would have eaten 1 whole pizza, right? I have to eat another whole pizza because I have to get to 3 holes. So there's 1 piece, 2 pieces, 3 pieces, 4 pieces, and 5 pieces. I have now eaten another whole pizza, if you want to say that. But I need to get to 3 whole pizzas. So to do it again, 1 piece, 2 pieces, 3 pieces, 4 pieces, and 5 pieces. I have now eaten another whole pizza. But in addition to the whole, I also have to eat part of another pizza. How much of another part do I have to eat? Well, I have to eat 2 more pieces of a pizza cut into 5 pieces. So I have to bring out another pizza and I eat 1 piece and I eat 2 pieces. I only eat a fraction of that last pizza. I eat 2/5 of that pizza. Now, if I want to change my mixed number 3 2/5 into a fraction, I have to count up all the pieces that I've eaten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and then on the bottom, 2 more, 16 and 17. So I have eaten a total of 17 pieces. Altogether, how many boxes did I color in? I colored in 17 pieces, right? Because that's how many I ate. How many parts is each bar cut into? That should be 5, right? Each one's cut into 5. That's the denominator. So altogether, I have eaten 17 pieces cut into 5 parts. 17 pieces cut into 5 parts. I have just converted my 3 2/5 into a fraction. It's called an improper fraction because the 17, the big number on top, is bigger than the bottom number, but it's still a fraction. Here's a shortcut for converting a mixed number to a fraction, because I guess you're not going to want to draw all those pizza bars every time you want to convert a mixed number to a fraction. So the shortcut is the whole number, this 3, times the bottom 5 plus the top 2. And then you put it over a 5. So 5 stays a 5, stays the bottom number. So I have a song for that. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. So that might help you to remember it. Whole number times the bottom plus the top, clap, clap. All right, let's move on and try another one. 2 1/5. We want to convert that to a fraction. 2 1/5 is a mixed number that can be rewritten as a fraction. Therefore, it is a rational number. So we're going to draw our boxes. We need to have how many full pizzas or full boxes? We need 2 full ones cut into how many pieces? 5. Could it be a different number on bottom? Yes, it could. Could be a 6, a 7, 8, 9, 10, any number, right? You just have to cut it into smaller pieces if it was a bigger number. So now we have to get to 2 wholes. So let's try with the first one. 2 pieces, 3, 4, 5. There's my first 1 whole pizza. Do it again because we need 2 wholes. Color in each piece. Okay, there's another whole. 1 and 1 makes 2 wholes. There's my 2 wholes. Now I have to have a fractional part of the last pizza. Okay, that's 1 piece colored in out of the 5 pieces. Okay, so we can say altogether how many boxes have been colored green? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 green boxes. And altogether, how many parts is each bar cut into? That should be your denominator. That's 5. Then we put the 2 together and we get our fraction, our improper fraction of 11/5. Remember, the bottom number stays a 5. The 11 comes from the number of green squares we colored in. And again, we could use our shortcut. Whole number 2 times the bottom 5, that gives me 10, plus 1, that gives me 11. That's where my 11 comes from. So whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. Whole number times the bottom plus the top, clap, clap. And you could keep singing for me. Whole number times the bottom plus the top, clap, clap. Let's go on. We are now going to write some mixed numbers as fractions. We're going to use our shortcut method because drawing those all out would take you a long time to do your homework. So we're going to use the whole number times the bottom plus the top, clap, clap. Let's see how that works. Well, what is 4 2/3 written as a fraction? Which one do you think it is? Remember, it's going to be 4 times 3 plus 2. Did you figure it out? Which one can we eliminate? 11/3, you're gone. That's not the answer. And 14/3, you're gone because that's not the answer. So 12/3, 4 times 3 is 12, plus 2 more. Oh, it should be 14. 12, 13, 14. Should be 14. I'm going to fix that in just a moment. Look at me. I made an error. Mrs. Claus made an error. So this should be a 14 because 3 times 4 is 12 plus 2 is 14. 14 thirds. Okay. Let's move on. Hopefully the next one's right. Whole number times the bottom plus the top. Clap, clap. All right. Next one. 2 and 7/8. See if Mrs. Claus gets this one right. 3 choices. 22/8, 17/8, and 23/8. Take the whole number 2 times the bottom 8. That's 16. Add 7. 17, 18, 19, 20, 21, 22, 23/8, right? Should be the answer. Let's see if that's the one that stays. Goodbye 17/8. Goodbye 22/8. Yay, it worked. Okay, 23/8 is the answer, and this is true. So we're going to move it over here. There it is, 23/8. Okay, let's try another one. First, our shortcut, whole number times the bottom plus the top, clap, clap. Okay. And the last one, 8 and 3/4 is equal to, here are your choices. Which is the correct answer? Okay, goodbye and goodbye. We are correct. 35/4 is the correct answer. Let's move it over here. And we get to sing our song. Whole number times the bottom plus the top. Clap, clap. All right. Oops, gotta clear this. Now it's your turn. Give it a try, making a mixed number into a improper fraction. See you in a minute. Welcome back. Let's continue. Now we're going to write decimals as fractions. So we have this decimal right here, 0.6. How do you say 0.6? Remember that decimals have a place value, right? If I was to do this, I would put the 6 here, and that's called your tenths. And the one after that is called your, what's it called? Type it in, hundredths with a TH, right? And the third square is called, anybody remember? Thousands with a TH. Thousands is the third box. So hundreds, should probably move that a little bit over. However, okay, so how are we going to write 6? That's 6.6. Well, we have to say it as the number that it lands on. So the 6 landed in the 10th spot. So it's going to be 6/10. Okay, and we're going to say it out loud, 6/10. This decimal can be rewritten as a fraction. Therefore, it is also a rational number. Decimals are rational numbers. Any number that can be written as a fraction is a rational number. So we have 6/10. So we said it out loud, 6/10, and then we put the 10 on the bottom and the 6 on the top. How many total parts are there? There are 10 total parts. How many parts does 0.6 represent? 6 of the 10 parts. So to convert a decimal to a fraction, read the decimal aloud, 6/10. The bottom number of your fraction is the place value of the last digit in your decimal, so 10. And the top number are the digits in your decimal, so 6. That's where we get our 6/10. Let's try another one. 0.45. This decimal can be rewritten as a fraction, therefore it is a rational number. It's 45 hundredths. Again, if I was to take my place value, it's my decimal. We have tenths, then we have hundreds, and we have thousands. The 45 goes here. So I read that as 45, and it landed in the hundredth spot. So I have to say 45 hundredths. That's where the 100 on the bottom comes from. How many total parts are there? This time there are 100 parts. How many parts does 0.045 represent? Or 0.45? 45 parts. To convert a decimal to a fraction, read the decimal aloud, 45 hundredths. The bottom number of your fraction is the place value of the last digit in your decimal, so hundredths. The top number are the digits in your decimal, 45. Okay, let's give a few more a try. We're going to write 0.7 as a fraction. Here are our choices. Hopefully the right one appears here. Which is the correct answer? Goodbye 700ths. Goodbye 10/7. 7/10 is correct. Move it over there. Okay, next one. Read the decimal aloud. 7/10. The bottom number of your fraction is the place value of the last digit in your decimal. It's in the tenths place. The top number are the digits in your decimal, 7/10. Try another one. 0.64. How would you say that number? Well, we're to do our place values. We have tenths, hundredths, and thousands. Let's put our number in there. It lands in the hundredth spot. That's 64 hundredths. So let's see which one could be our possible choices. There's our choices. I said the number out loud. Which one would it be? Not that one. Not that one. 64 hundredths. Did you guess it right? Good for you. Remember, read the decimal aloud. The bottom number of your fraction is the place value of the last digit in your decimal. In this case, it was 64 hundredths. 100 is the bottom number. The top number are the digits in your decimal. In this case, it was 64. Try another one. 0.752. Well, let's do our decimal place first of all. So we put the 7 here, put the 5 here, and we put the 2 here. How do we read that number if we were to say it out loud? Tenths place, hundredths place, thousands place. 752 thousandths. The 2 is the last number, so that's what place value we read. We read the place value of the number that's in the last spot. So 752 thousandths. Now let's see if you can figure out which fraction is the correct one. Here are choices. Got it? You think you have it? Let's see if you're right. Goodbye that one. Goodbye that one. Did you guess 752 thousandths? Then you are correct. Good job. Remember, read the decimal aloud. The bottom number of your fraction is the place value of the last digit in your decimal. The 2 landed in the thousandths place, so we're going to have 1,000 on the bottom. The top number are the digits in your decimal, 752. Okay, now it's your turn to write some decimals as fractions. Welcome back. Let's continue. Writing a whole number as a fraction. How do we do that? Okay, 34. How do I write that as a fraction? Can I write it as a fraction? Yes, 34 can be rewritten as a fraction. Therefore, it is a rational number. All rational numbers can be written as a fraction. So yes, let's pull something down for a minute. Okay, let's continue. 34 over 1. Because 34 divided by 1 is really 34, right? So you can put a whole number over the number 1 and make it a fraction. So any whole number can be turned into a fraction by writing the whole number over 1. Let's try another one. 2,984. How can I make that a fraction? It can be rewritten so that it is a rational number because you can write it as a fraction. Becomes 2,984 over the number 1. Any whole number can be placed over the number 1, okay, to make it into a fraction. Let's try some more. How do you write -7 as a fraction? Whole number can be rewritten as a fraction. It is a rational number. -7 over 1. It doesn't matter that there's a negative sign there. It still can be written over 1. any whole number or any integer can be turned into a fraction by writing the whole number over 1. Okay, it's your turn to give some whole numbers a try, writing them as a fraction. See you back in a moment. Welcome back. Let's continue. Now we're going to talk about classifying rational numbers. Okay, so we have a set of whole numbers. Whole numbers are all the counting numbers you would have learned in kindergarten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and you could go forever and ever and ever because numbers never end, right? They're all the positive counting numbers. So there it is. Whole numbers are positive counting numbers that you learned in kindergarten, but they also include 0, okay? Remember that 0 is included in that. All right, what about the next set? We have integers. What are integers? Well, they include 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the numbers that are whole numbers, but they also include all the negative numbers that are whole numbers on the number line. -1, -2, -3, -4, -5. They include all those, and they include all of those. -6, -7, -8, etc., all the way into forever, right? Those negative numbers never end going to the left, and they never end going to the right. So integers include all of the whole numbers, but they also include all of the negative whole numbers. Integers are positive and negative counting numbers, also including 0. And there's one more subset that we're learning in 6th grade, the rational numbers. That's what our topic is on today. What are the rational numbers? Well, they are all of the decimal pointed ones or all of the fractions, right? 1.25, 1/5, 1 and 3/7, 1.75, 2.3, 3.4, 4.8, 5.9, 6.2741, any decimal and any fraction. I'm just going to write one in here because I didn't put any of those in my PowerPoint slide here, but any fraction is also a rational number, or any negative fraction is a rational number as well. And also any negative decimals, -1.25, -1.5, -1.75, -2.3, -3.4, -4.8, -5.9, and any other decimal or fraction you can imagine is a rational number. So rational numbers include the positive and negative counting numbers, also including 0, and they include all the decimals and fractions in between whole numbers and integers. So they're every other number in between the numbers on the number line, okay? Okay, rational numbers include integers and whole numbers. So if the circle is inside a bigger circle, all those numbers that are in the smaller circle are also part of the bigger circle. So the whole numbers are also part of the integers, and the integers are also part of the rational numbers. Whole numbers are integers and rational numbers. Integers are just integers and rational numbers. Okay? And integers include whole numbers, right? Okay, we'll go on. Give some of these a try. So in summary, let's talk about it for a minute. Whole numbers are positive counting numbers that you learned in kindergarten, including 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. The ... means it keeps going forever and ever. Integers are the positive and negative counting numbers, also including 0. So it's still your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, etc. But it's also your -1, -2, -3, -4, -5, -6, -7, -8, -9, ... Goes on forever in the negative direction. And rational numbers are positive and negative counting numbers, but also they are decimals and fractions in between whole numbers and integers. So they're all the green numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the negative whole numbers, -1, -2, -3, etc. And they are also all of the decimals, and they could be all of the fractions and all of the negative decimals and all of the negative fractions as well. So let's classify some numbers. Let's find out where the number belongs. Where does the number belong? Here's our chart, rational numbers, integers, and whole numbers. Here are some numbers that we're going to classify. So we have the number 75, -3, 3/4, and 0.35. So 75, where does that belong in this chart? Does it belong as a rational number, an integer, or a whole number, or a combination of many, or both, or all three? Let's see where 75 is going to end up. Let's keep moving it. Where is it going to be? 75 is a whole number. I count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 75. It is a whole number. But it is also an integer because integers include the whole numbers. They include the positive numbers. But it is also a rational number because rational numbers include all the integers and all the whole numbers. So 75 is all three. How about -3? Where does that belong? -3. See where it goes. That is an integer. It is not a whole number, but it is also a rational number. So remember, if it is considered in the circle of the bigger circle, it's included in the bigger circle as well as the smaller circle. So -3 is an integer and a rational number. Remember, integers are all of the positive whole numbers and the negatives. Okay, now we have 3/4. Where is that going? That is a rational number, and that's all that it is. It is not an integer because it's a fraction. It's not a whole number. It's not how we would count in kindergarten. We wouldn't count 1/4, 2/4, 3/4, right? How about 0.35? 35 hundredths. That's a decimal. Where is that going to end up? Right there. It is a rational number. It's not a whole number. It's not an integer. It's only a rational number. Let's do a few more. 101, -8, 2/5, and 14.1. Where does 101 belong? Why don't you pause the video, try these four numbers, classify them, and then come back and check that you got it right. Okay, 101, where is it going to end up? Correct, it is a whole number. But if it's a whole number, it's also an integer. And if it's a whole number and an integer, it's also a rational number. What about -8? Where's that going to go? That is just an integer and a rational number. It is not a whole number because whole numbers are only the positive whole numbers, not the negatives. So it's an integer and a rational number. What about 2/5? Where's that going to end up? 2/5 is a fraction. It's only a rational number. And what about 14.1? 14.1 is a decimal, and that is only a rational number. Okay? Okay, let's talk about some higher order thinking. I did want to put in a your turn. So the your turn will appear, should have appeared for you already on the video. You just didn't get a your turn slide. Okay, higher order thinking. DeMarcus says that the number 24/6 belongs only to the set of rational numbers. What is his error? 24/6. It's a fraction, right? So it would be a rational number, right? But let's think about this. Can we use 24/6 and put it into a division equation? Of course. Remember, a fraction is always really a division equation. Which number goes on the inside of my house? The 24, the top number, correct? Which one goes on the outside of my house? The 6. 6 divided by 24 is equal to 4. 4 times 6 is 24. 24 minus 24 is 0. So 24/6 is really 4. 24/6 is equal to 4. Now, how would I classify 4? Sometimes you have to rearrange numbers to figure out all the names that belong to them. 4 is a whole number, right? It's also an integer, and it's a rational number. So DeMarcus was wrong because 24/6 is really all three. It's not just a rational number. It's a whole number, an integer, and a rational number. Sometimes you have to rearrange the numbers. Okay, let's take a look at another one. Is it possible for a number to be a rational number that is not an integer but is a whole number? So could a rational number be a whole number but not be an integer? What do you think? Think about our chart here with our whole numbers on the inside, right? Whole numbers go here, integers go here, and rational numbers go here, right? So the person is saying, can a number be a rational number in this category here, but not be an integer, not be here, but also be here? Can it be that way? No, right? Because if it's a whole number, it's automatically in the second category, and then it's automatically in the third category. Works from the inside out. So the answer is no. Every whole number is also an integer. Okay, your homework then is going to be on Google Classroom, and I'm going to say goodbye to you. If I can get that working right. Have a good day. Bye.